The ping pong ball is at a resting state. It will stay in this state unless acted upon by another force. This is Newton's first law, the law of inertia. What stays in motion stays in motion, and what stays at rest unless acted upon by an opposing force. In this case, if you ignore potential energy, the ball was at rest, and the opposing force that causes it to accelerate is the paddle. Momentum is the amount of inertia in a moment and is calculated by the velocity times the mass. The ping pong ball, despite having a little amount of mass, may still have a big velocity, ergo having a lot of momentum. The paddle causes an unbalanced force, therefore the ball accelerates. Balanced forces will make the object stay at rest, or if the object was already in motion, it will stay at a constant velocity.
Velocity is the rate of which an object is traveling and the direction it is traveling in. Velocity can be found by measuring how far the object traveled and measuring how long it took to travel that distance, i.e., distance over time. In most cases, the object does not stay in motion due to friction and air resistance.
Friction is the force that innately opposes motion, so if the ball were to roll across the table, friction would stop the ball. Air resistance happens when air molecules slow down an object in the air. For example, if the ping pong ball is in mid-air, the air molecules will slow it down while it is still moving. As the ball moves through the air resistance will slow down. In order for the ball to have acceleration, the force must be unbalanced. Now, force is the sum of all forces in an object. In a free body diagram, opposite vectors are subtracted. Vectors in the same direction are added. Perpendicular vectors are combined using the Pythagorean theorem. Vectors with an obtuse or acute angle are combined using the law of cosine. If the net force does not equal 0, then the object accelerates. The ball has forces acting upon it: gravity, air resistance, applied force, and when these vectors are combined, you get the net force. Newton's second law states that the net force is directly proportional to acceleration, while mass is inversely proportional to acceleration. Therefore, if mass increases by a factor of 2, acceleration decreases by a factor of 2. If net force increases by a factor of 2, acceleration also increases by a factor of 2. The net force is equal to the acceleration times the mass. Acceleration is equal to the force over the mass. Say that you have a ping pong ball and a basketball. If you apply the same force to each of the balls, then the one with greater mass will have a smaller acceleration. This is why ping pong balls are so light, so they can have an easier acceleration. But if the mass is really small, then the player will have to exert less force to make sure that the ping pong ball hits the other side of the table.
The third law dictates that for every force, there is an opposing but equal force. As my paddle hits the ball exerts an opposite but equal force on my paddle. Same thing applies to when the ball hits the table. But wait, didn't you say that opposing forces cancel out? Yes, they do. However, both forces aren't acting on the ball. They're acting on two different objects. The ball exerts a force on the paddle, and the paddle exerts a force on the ball. Also, the reason why I don't accelerate like the ball is because I have more mass. Since acceleration is force over mass, the force is much smaller than my mass, and the acceleration is not noticeable. This ping pong match is an example of physics at action. Players apply forces onto the ball using their ping pong paddle, making it accelerate. The force and the acceleration can be found by using Newton's second law and the equations F equals ma and A equals F over m. Force vectors can be drawn and combined to show the velocity of the ball. The first law shows that the ball naturally has inertia and wants to stay in the same state, but air resistance and gravity keep it from doing so. We also know that the ball has momentum, which is expressed in mass times velocity and is the amount of inertia in motion. The velocity of the ball is how long it traveled in a certain direction over how long it took to travel that distance, while acceleration is the change in velocity. The forces that are applied to the ball are also applied back equally on the paddle.